Hello everybody, welcome to this new session, Communication Protocols in Vehicle Diagnostics and Onboard Diagnostics. So in this session or lesson, we are going to see elaborately about the various types of communication protocols, communication pathways that are involved in diagnostics. Vehicle diagnostics or and onboard diagnostic systems rely heavily on in-vehicle communication protocols to exchange data between the electronic control unit and diagnostic tools and external service and equipment. So naturally, this is kind of common sense. You require some protocol to exchange the data. You require some procedure to exchange the data. And the data exchange is always between electronic control unit and external service equipment. And these communication protocols ensure interoperability, standardization, efficient retrieval of vehicle status, and fault information. Okay, because of the standardized communication protocols, efficient data transfer is ensured. And below is a detailed explanation of latest and most widely used communication protocols in vehicle diagnostics and OBD systems. So let's see. First is ISO 91412. This is a slightly older protocol and it is primarily used in older Asian and Chrysler vehicles before 2008. And it is a serial communication type, and as you can see, speed is very less compared to the modern protocols. Speed is just 10.4 kilobytes per second, and wiring is single K line with optional L line for wake up. And the function is it communicates with ECU over simple asynchronous serial communication line. Diagnostic tool sends a request and ECU responds. Of course, the biggest advantage, the biggest benefit is simple and inexpensive. And cons is when it comes to the disadvantages, naturally because of its slightly vintage status, it is slow and it is not exactly suitable for modern vehicles with multiple ECUs. Okay, so this protocol standard was developed before vehicles had multiple ECUs. So naturally it is a bit slow. So let's see further. Next evolution or evolved protocol is ISO 14230, Keyword Protocol 2000 and KWP 2000. Okay, so KWP is acronym for Keyword Protocol, and it is used in vehicles mainly from 2003 to 2008. Again, this is also serial type, and speed is 10.4 to 125 kbps. As you can see, the speed has drastically improved from the previous protocol, and its variants is it can run over K-line serial or CAN, and function more flexible and efficient than ISO 9141. Supports multiple services. It is capable of reading DTCs. It is capable of erasing DTCs, etc. The biggest pros is it is backward compatible, supports both slow and faster modes. Okay, so it is compatible from ECU to scanner and also from scanner to ECU. And the biggest disadvantage is it is obsolete for modern CAN-based systems. And next, when it comes to improvement, it is ISO 1615765-4, and it is also called CAN Control Area Network. So this is used in all vehicles, especially OBD-II compliant from 2008 onwards. Now, CAN network or control area network is arguably the most popular communication protocol in automotive industry so far. Of course, some modern protocols are making foray into the market, but even today, CAN stays a force to reckon with. And the type is differential serial bus. Speed is 250 kbps to 1 mbps. As you can see, from 125 to 1 mbps, the speed has increased, and the function is primary protocol for modern OBD-II diagnostics. The biggest advantage is fast and robust. It is multi-master communication and it handles multiple ECUs simultaneously. And one more advantage I missed out mentioning here is it is a very mature technology. So very lot of manpower who are skilled in CAN are available in the market. And the biggest disadvantage is it requires more complex hardware. And also please note, OBD-II mandates CAN support for all vehicles sold in US after 2008 and in Europe after 2011. So because of its robust methodology or robust presence, OBD-II has mandated CAN support. All right. So to proceed further, next is SAE J1850. All right. So J1850 pulse width modulation, it is used by Ford vehicles and speed is of almost 41.6 kbps and wiring is dual wire. And when it comes to J1850 variable pulse width, the used by General Motors and speed is 10.4 kbps. Wiring again is single wire and pros is widely used in North American vehicles before CAN standardization. Cons legacy systems only slower and being phased out. All right. Now coming to UDS, Unified Diagnostic Services ISO 14229, and it is used in all modern vehicles, especially after 2010, and especially in advanced diagnostics. All right, and this Unified Diagnostic Services is built on the top of CAN FlexRay Ethernet, and function is standardized diagnostic protocol across the OEM and supports DTCs, ECU reprogramming, actuator testing, and security access, etc. As you can see, Unified Diagnostic Services supports a multitude of applications. The biggest pro is it is a rich feature set. It can be used in multitude or a gamut of features, and it is standard across OEMs and services support. Next comes the cons, complex to implement without proper tooling. All right, so this requires a very standardized tooling. That is the only disadvantage as far as I personally believe, and also as far as the common belief in the industry is. Next is DOIP, Diagnostics over Internet Protocol. This standardized as ISO 13400, and it is used in latest vehicles from OEMs like BMW, Mercedes-Benz, Jaguar Land Rover, Volkswagen, etc. And the medium is Ethernet, speed is 100 Mbps or more, and function is UDS over Ethernet. And Pro is the biggest advantage, it is high data rate. As you can see, speed is 100 Mbps. And the biggest function advantage is high data rate for ECU flashing and diagnostics. Okay, so and it also allows for remote diagnostics, future proof for SDV ecosystems, and the biggest disadvantage is costlier implementation and requires Ethernet hardware. So again, this requires some specialized hardware, and implementing this specialized hardware is a slightly expensive affair. Next most popular communication protocol is FlexRay, and used in high performance and safety critical systems like BMW 7 Series, Audi 8, Audi A8. So as you can see, some very state-of-art vehicles, some very modern vehicles like BMW 7 Series and Audi A8 use this FlexRay, and that only shows the efficacy of this particular protocol. And as you can see, it has a speed up to 10 Mbps, which more than suffices for the data transfer. And function is real-time communication, less used for diagnostics, but UDS over FlexRay is possible. And Pro is the biggest advantage is deterministic timing and redundancy. Okay, so in case any protocol fails, you have a redundant or a backup protocol to data transfer. And con is expensive, limited to premium segments. Okay, so this is a disadvantage. It is limited to premiums, it is expensive, but it is a very efficient protocol. The very fact that it is used in luxury cars shows the efficacy of this FlexRay. Last but not the least, LIN, local interconnect network. It is used for subsystems like seat motors, window regulators, and speed 20 kb. It has a very moderate speed. It is not exactly a very high speed data transfer, but it has a moderate speed of 20 kbps and function low cost diagnostics and control of non-critical systems. Okay, this sentence is very important. Low cost diagnostics, and Pro is cheap and simple, and Con is limited speed and capability, not suitable for central diagnostics. Now below is the a tabular comparison for all the protocols. I request all of you to pause the video and study this very carefully so that you can have a proper comparative study between each protocol. Okay. Now, some modern protocols like wireless diagnostic protocols are emerging into the market, and with the rise of connected cars, wireless diagnostics are becoming more common. Now, the first most important wireless protocol is Bluetooth Wi-Fi, and which is enabled with the help of OBD dongles. Now on the right side you can see a photograph of OBD dongle, and actually lot of OBD dongles are available in eBay, Amazon, Flipkart, and these are very much there are a lot of individual manufacturers who are manufacturing OBD dongles and manufacturing and marketing through online websites, and it is used by aftermarket scan tools like for example ELM 327 based adapters. Limitations: slower than wire diagnostics but convenient for basic scans. Now when it comes to 4G and 5G telematics, it is enabling remote diagnostics, and the usage is OEMs Tesla, BMW, Ford, they use cellular networks for remote diagnostics, over the air updates. Okay, and last but not the least, RFID, radio frequency identification, key based diagnostic, and some manufacturers use NFC for quick service authentication. All right, so this protocol called NFC is used for authenticating the right vehicle. Now coming to the security protocols in diagnostics, modern vehicles implement security to prevent unauthorized access. Okay, so security is very important, and for security onboard communication, there is a standard called ISO 21434, which is totally a standard for cyber security. And with the help of the standard, or by implementing the standard, implementation of the standard leads to authentication of diagnostic messages. Next, when it comes to TLS and SSL, there are encrypted Ethernet diagnostics. And last but not the least, hardware security modules. Now, lest you think that I am trivializing this or I am putting this in a very uh, easy manner, let me tell you, all these protocols which I have mentioned, they are huge chapters in itself. Okay, so I'm just giving you a brief overview how so many protocols are available. What are the so many protocols available in the market that can be used for this diagnostic purpose? And when it comes to transport protocols, ISO TP, ISO 157652 used over CAN to segment and reassemble large diagnostic messages exceeding 8-byte CAN frame, and CAN DB manages diagnostic message flow and ensures correct delivery between tester and ECU. All right. So in this lesson, I have extensively covered all the various types of protocols used in various types of diagnostics throughout the world. Thank you.